Right, so for the last day, Code Chronicle, the entire description is like extremely long and it's really detailed, but the main idea is we have some blocks separated by double new lines, and what we have to do is to count the number of hash symbols in each column and then make sure that if we take any two pairs, the sum is less than 7 or equal to 7, I guess, because there are 7 rows. And we also have to classify each block based on where its full line of hash symbols is. So for instance, this with the hashes at the top is a lock and this one is a key. So we have to find all the locks and keys that are matching. Basically, it's the idea. And one thing to I guess we have to find the pairs that are not like overlapping, because they don't have to be full, like they don't have to have all the sums to 7, so they don't have to be matching keys and locks, they just don't have to overlap. So maybe that's something that can be confusing for someone, like they might want to try to have them like you see this one and this one, the lock and this key, they look like they can, I guess they cannot fit together, but you get the idea. They don't have to be all hashes after you combine them, there can be empty spots, so that's the first thing. And yeah, I solved this one using Common Lisp, and the main difficulty was with parsing the input, where I mean ChatGPT actually helped, but it's really hard for these obscure languages to just give it a problem statement and solve the entire problem. That's impossible. You have to come up with these small functions, because otherwise it's really bad. But let's go through each one and see how it looks like. I mean, the main difficulty for me comes from the number of parentheses and formatting the functions. Like it's that's the most difficult part of Common Lisp, because I mean I did a lot of Haskell, so I know functional, but yeah, actually coming up with all these parentheses and all of these keywords, also they are a bit annoying. But first of all, we had to read all the lines, and I mean I had to make sure that I knew how to do this one before day 25, because I knew it's gonna be something like read all the lines at some point, so already knew how to do this one. We just use read line function, and this is like std in C, so you just specify which file descriptor to use, and then we just read all the lines into a list, right? And in this problem you can see that we have a list of lines, but they are split by double new lines. So the next step was to split them into blocks. So this function does exactly that. We take the list of all the lines and we group them. Maybe there is a function group by in, I mean there should be, like it is in Haskell. And yeah, we group them such that they are split by the empty string, which is basically this one right here, right? So we try to group them like that by the empty string, and we get a list of strings. It's straightforward. Then to classify the schematic, I looked only at the first element, so car, which is funny, I don't know why it's called car. I'm used to calling it head, but whatever. So we take the first item in the list of a schematic. So schematic is just this part, right? And if the entire line is filled with hash symbols or hash characters, we know that it's a lock, otherwise it's a key, right? So again, if you have all the hashes at the top, it's a lock. If you have all the hashes at the bottom, it's a key. That's the idea. Then the next one was to parse, and this is where I needed some help because I couldn't come up with these functions. Like, I mean, I knew the idea, but I didn't know how to actually solve it in Common Lisp, which was kind of annoying. And also this other function, this was I think this was the biggest one that I didn't know how to do actually. Splitting the line by like the group by function, basically that's what I needed here. If we had a group by function, this would be much easier to implement, but I don't know, like I just try to do it myself just for the memes. So to compute the column hashes, we take a schematic and we want to get the number of hashes in each column. So a list that would be like what, 1 2 3 4 5 items, and it's gonna contain 1 6 4 5 and 4, whatever. Right, and I know in the problem is the other way around for some reason. I count the dots, but I wanted to count the hashes. That's still fine. So yeah, we just go through each column. We basically have to map. So in Haskell, how I would do this one, because when you do a map over a list of strings, you actually map the rows, right? But we want to map over the columns. So how I would do that is go with an index from 0 to the number of rows, or I guess columns, yeah, that's the columns. And I would map with the end function, but I see here it uses aref, not end. I mean, I would use end. I don't know what's the difference, honestly. But you know, in Haskell it's that, 2 exclamation points. But yeah, I mean, whatever. So it goes over each row and it does end on that row. So it, in the end, is gonna be the column. That's all it matters, right? So we count how many hash symbols, and that's gonna be our schematic converted into a list of numbers. So much easier to understand. Then I just wanted to see how using structures is like in Common Lisp, because yeah, I mean, I don't know, I don't know how I feel about it, because it's, I mean, it's decent, but again, like in Haskell, it's more simple, I would say. Like this makes me feel like Haskell is actually really simple as a language. Like by simple, I mean minimalist in a way, like compared to how complicated Common Lisp looks like. So yeah, then we have this parse schematic function, which its job is to just construct this schematic thingy. So it takes in the list of lines, right? And it gets the type using this function. It's a lock or a key, and then we get the column hashes. So how many hashes each column has. And yeah, we just build the schematic with make schematic. I guess make schematic is automatically generated. This reminds me of the stack language that we did, where we auto-generate constructors for structures. Kind of cool. And not only that, but it also generates the field getters, same way as we did in our language. So that's kind of cool. Anyway, so yeah, basically to parse the entire input, I made a separate function, which is just going to map this parse schematic over all the blocks in our input. So yeah, basically at this point, we just converted this entire list of strings, or I guess this entire string, list of lines, if you will, into a list of schematics, and the schematic is just a type, lock or key, and the list of the column hashes. Okay, and next we check the compatibility, and again, to check the compatibility we don't need to have them like puzzling together, so to speak, right? We just want to have different types, so one is going to be a lock and one is going to be a key. And the other important thing is if we sum up the like column 1 with column 2, like pair by pair. Here I wanted to do like zip width and stuff, but I couldn't figure it out, so I did. I guess every makes even more sense, honestly, but because it's only one call, but yeah, whatever. So we iterate both columns, and then I did like adding them together, and then they have to be less than or equal to 7. Yeah, here if I did it in Haskell I would have done like zip width plus, right, and then all less than 7. So that's what I wanted to go with here as well, but yeah, and that's why I say here you might do this instead, like check if they're actually equal to 7, but no, you just have to be, you can have like empty spaces in the key. So yeah, and then to count the compatible pairs, compatible pairs, we just make 2 for loops. We just need to generate all the combinations of pairs, right? And again, I is gonna be less than j, so we want to get all the unique pairs, and we check if the ith one and the jth one are compatible. If they are compatible, then we just increment the counter, and that's gonna be the answer. So pretty straightforward. And yeah, the main function, again, this one I have no idea how format actually works. Kind of weirded out about this formatting thingy, but I will assume it's similar to C, but it's in reverse for some reason. If anyone knows why it's like that, kind of strange. But yeah, after all, we just have to count the compatible pairs of our schematics. So yeah, I mean, as any functional language, this looks really nice, except for parsing the input, which is the ugly part. Like always in functional languages, the parsing of the input is the part that sucks. But the actual problem itself, kind of nice, right? So yeah, and that's kind of all for day 25. Bogus. I don't know why. Or what I might have done here, but wait, let me. They just click something? I don't think so. Anyway, SBCL, I run it like this, and I actually get it. I guess in the makefile I did something stupid. Okay, dash script, right? We have to use minus script for the makefile. Yeah, anyway, so that's the answer for part 1, and in fact there is only part 1. So yeah, actually the historian was in his office, so that's funny, right? It was in his office all along. Okay, and I actually saved this one. I wanted to see it. Okay, nice. So it was just the end screen as usual, and yeah, kind of cool. This one is honestly, this was the year that I like the most with the microcontroller stuff. That was the funniest one. I think which one was like with the animations. I mean, I think no, 2020. Nope, not even this one. No. I think it was like a really old one that I solved. Yeah, this one had the coolest animation, honestly, in my opinion, but I mean, I solved it like 7 years after it was created, so, but, or I guess 5 or 4 years, something like that. But, yeah, that's then everything we had to do for this year, and yeah, I actually completed all the entire script here, so it's gonna show all the days. And yeah, I guess that's it for today, and probably also this year, right? Maybe there's gonna be a review for the entire AoC, who knows? You'll have to stay tuned to see that. But yeah, you see you have a script that runs all the languages. Now, obviously they're gonna be slow. I didn't try to go for the most efficient solution, or I guess most efficient language if you'd ask me, Prolog and JavaScript. These were the slowest ones. And yeah, I mean, surprised actually that my language was actually good enough to solve at least one day, and it's also pretty fast. Like, come on, it's quite fast, even though it's really bad as implementation. We'll have to improve it. Like the next project is gonna be improving the stacklang, maybe even doing like LSP and three-seater for it. Why not? Let's actually make a language that's gonna be the new hype, like the new Zig, basically. So why not? Let's try to get that. So yeah, that's it for today, and we'll see the next one.